Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet. In this we were doing linked list topic and pattern was reversal pattern. Today we will see the last question from this pattern, which is reverse nodes in K group. Although the category is hard, but trust me, the problem is really interesting. So you will be given a linked list, and as you can see example number 1, the question says key with K. Like here K is equal to 2, right? So in the entire linked list, you have to take K groups and reverse it. So as you can see, 1 and 2 means size is 2. So we will reverse and it will become 2, 1. Similarly 3, 4. So example number 1 is similar to the problem which we have solved, swap nodes in pair. So if you have not watched that video, I'll definitely recommend you all to go and watch that video first. So when it was only about 2 pairs, means we saw it in swap nodes in pair problem. But here instead of K is equal to 2, now the K can vary and hence it becomes the new problem statement. So let's see the constraint. The constraint says the number of nodes can be 5000, means 5 into 10 power 3. So definitely till n square means 5 into 10 power 3 multiplied by 5 into 10 power 3. It will become 25 into 10 power 6, and you know till 10 power 8 our code will not give us TLE. But beyond that it's not safe. How? Because we have discussed about this in our time and space complexity video. I'll attach the link somewhere here. But linked lists mostly have linear solutions with or without space. So we will see the brute force and optimized code here. First, let's see, we don't know how to reverse it. We don't know how to reverse linked list. Okay. Now suppose instead of linked list, if we had list. Okay. If we had list. And the question asked, ki reverse the values inside the list. How we could have done? For sure, I will start from 0th index, correct? And I plus k, which will go here, but I plus k minus 1 we have to take. So let's move back. So can I say, I will start my I pointer and j pointer from here, and we have to reverse it, right? So basically this node and this node we will swap. So it will become 3 and this will become 1. Correct. Now I plus plus and j minus minus. So here we will not swap because both are referring to the same nodes. So can I say this k has been reversed? Now next time the new I will become, do we need to do I plus plus or I plus k? Definitely I plus k. So again I will come here, correct? But I plus k minus 1 will go out of index. To reverse it, it's very important to have k groups of elements. But in this case, as we don't have, so we will not reverse it and we will stop. Okay. So means, can I say ki I will start running my for loop from int I is equal to 0 and till I plus k less than is equal to length of list, correct? And next I plus plus, no, I plus k. Okay. Now here, let's say left pointer will be I and right pointer will be I plus k minus 1. Now we will apply the 2 pointer concept, 2 pointer logic. How? While left is less than right, and now we will swap using temporary variable method. So inside this while loop we will swap. After swapping, we want to go for the next, so I should move with k times, right? So I plus is equal to k. So next time my I will be, can I say here? Yes. And j will be, j is nothing but, let's say, right pointer. So this is left pointer and this is right pointer. Okay. Now we can see ki yes, I to is in the range, but I plus k is out of index. So now for the next time, second for loop will not even run for it. Correct. And we can say ki yes, 3, 2, 1 reversed. But this to in list, how can we do in linked list? Very simple. Run the, start a current variable, one by one read the values and put in the list, okay, and apply this logic to reverse it. Done. Once reversed in k groups, read all the values and override. So it was 3 to 1, right? So override 3, override 2, override 1, and 4 will be as it is, 5 will be as it is. So now we can say yes, it has been reversed in k groups. But the complexity is, first so you have to read all the values and put in the list. So O of n. Now further O of n to reverse this, can I say? Now don't think this is for loop and while loop, so nested O of n square. No, it's not. Because you saw now, for loop, like for I, it has run for only one time, because next time I though it was there, but I plus k was out of range. So second time the for loop has not even run, right? And inside this it takes whatever is k by 2. Okay, so this for loop has run for total length divide by k. Can I say total length was 5, divide by 3 means 1, so only one time, and inside this k by 2, so n by k into k by 2, so in total it's O of n by 2 time complexity to swap the nodes or to reverse the nodes in k groups, right? After this, further O of n to override the values in the list. So total, can I say O of n plus n by 2 plus n, which is 5n by 2, correct? Although it is linear, but space wise also it's taking O of n extra. But what if the question says you have to reverse? Anyhow, you saw na, you have just overwritten the value. You have not swapped or reversed the nodes, correct? So what if without space you have to do? And that's what called in place method or logic of doing reversal. But before moving to that, I want to show you the exact code what we have discussed right now. So here is the code I have written, but before that, as you can see, the number of nodes can be 0 also, means if head is null, it does not make sense of reversing nodes. And second is, what if k is equal to 1? It says na k can be 1. So if k is 1, do you think reversal will make sense? Means it says reverse the nodes in 1 group. It means no reversal needed, right? So hence in both the cases, if your head null or k1 means you don't need to reverse and you can simply return your head, okay? Otherwise, you have to create list and start a current pointer from head, one by one, read all the values of the linked list and put in the list. After that, here is the logic to reverse in k groups. How? We have to run the for loop as discussed, I0 to I0 till I plus k less than list size, correct, and I plus is equal to k. Now I will be my left pointer, I plus k minus 1 will be my right pointer. Now using the 2-pointer approach, we will reverse with the temporary variable concept. After that, our list has been reversed in k groups. So now again we will start our current and index from 0. We will iterate in the entire linked list and overwrite all the values which has been encountered in the list. And once done, we can return the head. Definitely it will pass, as you can see. So if we will submit, this will get submitted. But this is very brute force approach because you have not reversed the exact code here, correct? So hence, now let's see how can we think and how can we do this problem without using extra space. Okay, so listen this very carefully because the logic is very easy, but only if you will be able to understand, okay? Now the thing is, we always followed that rule na, ki start or make a dummy node and connect it to the head, correct? Why? Because what if this will get changed? Then we can return dummy.next. Although without this also it is possible by adding in the base cases. But I prefer creating dummy node always because it feels easy. Okay, so now here is my dummy node. Okay, now till where I have to reverse? Can I say this? Can I say this? Yes. Okay. So if I have to reverse this, for sure 1 needs to be connected with this. Can I say that? And how can we connect this 1 to 4? For that, it is very important to reach here. Means by taking k distance. So means I will start my current from here. I will take k jumps, 1 jump, 2 jump and 3 jump. So after taking 3 jump, I will be standing here. So can I say my current is pointing to this, correct? And this is my next group. Can I say group next? Yes, yes. This is going to be my next group. This is my current group. And can I say this is my previous group? Yes. So although it is a dummy, but let's say what? Previous group also. Okay. Again, I have started my current from here. I took 3 jumps to reach here. I wanted this group. So 1 needs to be connected with this, 2 needs to be connected with this and 3 needs to be connected with this. Can I say? So can I say for 3, 2 is previous? For 2, 1 is previous. Listen it very carefully. And for 1, can I say 4 is previous? So can I say previous is nothing but like group next. Okay. So previous is nothing but this is my previous, correct? Okay, so to reverse it, this should be my current, okay? But current, so we have named this variable. So, you know na, how to reverse linked list. So to reverse linked list, we always learned while keeping the previous node with the previous name and current with the current. So let's rename this something else. Let's say, because it started to take k jumps now, so let's name it kth node. Okay, so kth node started from this, kth node took k jumps and it reached to this. Now it's time to reverse it. So for reversal, there should be a previous pointer and there should be a current pointer. Why I am saying this? Because I am assuming you know how to reverse a linked list. Because if you don't know how to reverse a linked list, then this question does not make sense. Okay, so to reverse it, previous is needed. How I decided 4 will be my previous? Because I knew to reverse 3 needs to be connected with 2, and for that 2 should be its previous. Similarly, 2 needs to be connected with 1, and for 2, 1 needs to be its previous, and similarly 1 needs to be connected with 4. Why? Because then only it will become 3, 2, 1. So 1 needs to be connected with 4, so 4 needs to be its previous, right? So previous will be my group next. Can I say current will be nothing but what? Where is my current? Can I say previous group dot next? Yes. So previous group dot next. Now I have my previous, I have my current. I have to write that reversal logic. So if you remember, suppose if you have to reverse the linked list, so you start your current pointer and you move your current until it becomes null. So null is the condition to stop when you have to reverse the entire linked list. But here you have to stop until this. So can I say until your node hits this group next, keep doing, correct? So can I write this ki while my current is starting from where? Can I say 1? So 1, reverse it, 2, reverse it, 3, reverse it, 4, stop. So can I say while my current not is equal to group next, not is equal to group next, now keep swapping. Now what is that swapping logic? To swap, what's this, like 1 dot next, we have to save this in next, right? So in my next, we save what? Current dot next. Now current dot next needs to be broke and it needs to be connected with this. So what should we write? Current dot next needs to be connected with its previous. Now in this case, so previous is 4. Next time for 2, previous needs to be 1. So what is 1? Current. So previous needs to be moved at now current. Currently current is what? 1. Next time I want this. How can I move? Current dot next? No. If we will move with current dot next, so from 1 we will move to 4, but we want to go to 2. So where have we saved this 2? In our next. So hence current is equal to next. Done. And now what will happen? 1 will connect to 4. Yes. 2 will connect to 1 and what? 3 will connect to this. Now how is this connected? 0, 1, 4, 5. If you will read this dummy, 0, 1, 4, 5. Where is my 2 and 3? So hence to read like this 0, 3, 2, 1, 4, 5, can I say my previous group needs to be connected with this 3? And what is this 3? Kth? Yes. So what we have to write after this line? Can we say we have to write previous group dot next, which is currently connecting with what? 1. We want it to connect with 3. 3 is nothing but kth. So now I can say ki my previous group next is connected to 3. So now if you will read the linked list from dummy, so it's like 0, 3, 2, 1, 4, 5. Can I say it has been reversed? So to return the head, definitely whatever is dummy, dot next is my new head. So dot next means 3. So it will return as 3, 2, 1, 4, 5 and done. But in this case, so it was only regarding one group swap. What if for the next group? So again, for this group, the previous group was this. Can I say? Just one node behind it. Similarly, for the next group, what if 6 was there? Then though it needs to be reversed. So for it, the previous group needs to be, it's 3, 2, 1. So can I say for 4, 5, 6, previous group needs to be 1 again. So let me rewrite this again, okay, for you. Where were we? We were like, this is connected to 3, this is connected to 2, this is connected to 1, okay. This was my kth, correct, and this was my head. But currently the head, In the whole code, we have not changed head anywhere. So anyhow, head does not make sense. So for the next group, I want my previous group. So previous group should point to this, right? How can we come here? How can we keep a track of it? Because here the head will give us the previous. But next time, for the next time, let's suppose this is 6, na? 7, 8, 9. So for 7, 8, 9, we want what? Can I say 4? Because after reversal 6, 5, 4. So can I say 4 will be my new what? Previous group. So in that case, so we cannot rewrite or track with head because head was pointing to 1, not 4. So what should be the line of code? Before disconnecting this, before, like previously this was connected to this, remember? Then only we connected to 3, right? By writing this line of code. So before disconnecting it, let's save this one somewhere. Let's save in temp variable. So let's save in temp variable what? Previous group, okay, dot next. So what is my previous group earlier? 0. Dot next means earlier 1 was there, na? So let's save it in temp variable. Okay. So if you will save in temp variable, now you have the track. Now next time previous group, you disconnected this one to connect it with 3. Now done. 0, 3, 2, 1, this. Now after this what you have to write now? Just say key new previous group will be nothing but temp. So now the new previous group will not be this, but what? Nothing but temp. Temp. Yes. So this will be my new previous group. Now what you will do? Again you will restart your code from the previous group. So again you will start your kth node from here. You will take 3 jumps till 6. Correct? Let's say null here. So till 6 you will take. Next group will be null. Correct? Means 4 will connect with next group, that is null. So and 5 will connect to 4 and 6 will connect to 5. So it will become 6, 5 and 4. 4 is connected to null. But in this case, as you can see, 4, 5 is there. Means how you will get to know that you don't need to swap. When you will take like jumps, kth jump from here, 1 jump, 2 jump, you are supposed to do 3 jumps. Remember, k is equal to 3. So if you will take 3 jumps, after that the kth will become null. And if the kth is null, you can say ki yes, it's not there. What? No need to swap. Yes. Can we write the code for this? See, this is what we discussed. Base case will be same as it is. If head null or k1, no need to reverse anything. Now we will start a dummy node, make the dummy node, and its next we will connect to head. Now we can say 0, 1, 2, 3, 4 all are connected. Now previous group will start from dummy. As said, previous group will be at dummy. Now while true, it means we have to continuously do this line of code to reverse the k groups. Now what we are doing here? Kth node will start from previous group. Currently it's on dummy. I showed you right here. Kth node will start from here and it will take how many jumps? K jumps. And after taking k jumps, if it is null, no need to reverse. Because here you saw na 1, 2, 3, it was null. No need to swap, means 4, 5 will not get swapped. So hence we will take k jumps until it is null. Okay. If your kth node is null, means break. No need to swap that group. But first though it's not null. So now we want group next, means next group. And where is my k? At third node. So do its next will be my next group head. Correct? Why we need that? Because that will be my previous pointer. See, when we took 3 jumps, its next was my group next. Why we need that? Because this will be my previous node for what? Before reversing 1. So we need 1 to connect with previous, means next group. That is why we kept a track. Okay. So now group next will be my previous and current will be previous group dot next, means from 1 we will start. We will keep on doing the reversal until our current node hits the next group. Why? Because from here we started 1 we need to reverse, 2 we need to reverse, 3 we need to reverse, 4 we don't need to reverse. So that is also reason ki we have named this a variable, so that when we hit our current at 4, we can match it with group next variable. If it matches, it means this is a part of next group and we don't need to reverse it. Means this is not in the part. Okay. Now after reversal, we need to store our 1 somewhere, because 1 is going to be my previous group for the next group. Okay. And now previous group dot next, which is dummy currently, we need to connect with 3, not with 1. Okay, so previous group was this, remember, dot next is connected to 1 before reversal, but we want to connect with 3 after reversal, so that this is how it should look like, correct? So hence we have written previous group dot next connect to kth, and previous group means for the next group just one node behind was my previous, remember, for this was the previous, so for 4 5 this needs to be previous, so hence we need to save it somewhere. That's why we saved in temporary variable, and at the end we have updated this. Okay, now once done, what do you think? Do we need to return head because head was 1? So if you will return head, you will get 145, not the entire linked list. So how to get the entire linked list? If you have dummy node, just return dummy dot next, and we are done. So that's what we return, dummy dot next. So let's run the code and let's try to submit this. So this code will be optimized because space is constant here, because we have just took few variables. And regarding the time complexity, as you can see, we are taking how much time to reverse it? Definitely O of n. So the whole time complexity for this one is O of n. Space is constant. So this was a Java code. I hope you understood the logic. If not, as this is from the hard category, and if you are weak in reversal of the node, then definitely this question might feel a bit difficult. Then I will recommend you to give it a try once again. This was a Java code. Here is your C++ code with the similar logic and same approach, and here is your Python code with the similar logic and similar approach. So if you understood this, then definitely we can mark the last question from this pattern, which is reverse nodes in K groups, and we are done. So please do let me know if you understood or if you have any doubt in this problem. And if you are watching till now, then I will expect a subscription and a like on this video from your side. And that's it for this video. You will get the sheet link and my social media's link to connect in the description. Let's meet in another video with some more interesting questions, topics and patterns. Till then, keep learning, take care of yourself and your family.